So, to start with, what exactly is high availability? This is a term that you hear all over the place right now in our industry. High availability. It's something they just throw in when it comes to every single product that's out there. But what exactly does high availability mean? Well, some say it means uptime, the time that your server is actually up and running. However, that's not exactly the case. High availability actually goes well beyond simple uptime. It actually relates to accessibility of services. So you might have a server that's up, but not necessarily available to serve. As an example, let's consider Exchange. What if your Exchange database becomes corrupted and your server is still up, and individuals can still access the server per se, but not necessarily access their mailbox? Uptime hasn't been affected just yet, although it might be certainly if you have to bring the server offline. But you would not say that that server is available to serve, especially if its primary function is as an Exchange server. So in a sense, it is uptime, but it goes a little bit further than just uptime. Now some would say that it's actually fault tolerance, and it is similar to the concept of fault tolerance. However, typically when we refer to fault tolerance, we're talking about disks. We're talking about RAID levels. We're talking about mirroring or stripes with parity that allow your disks to continue functioning in the event of a single disk failure. So fault tolerance certainly would come into play if you wanted to have a system that was more highly available. It's not that fault tolerance would not be a technology that you would consider to assist you with high availability, but the two are not exactly the same. High availability can go well beyond disk fault tolerance in terms of providing services. So then others would consider clustering to be a synonymous term with high availability. And in many cases it is. Clustering technology allows you the ability to have multiple systems that are all ready to jump in, typically in an active passive situation. So, for example, you might have a server that's active and ready to serve, and if it goes down, the passive server has a complete duplicate of everything that's on the active server. It realizes that there's a problem and it has to assume the active role, and it jumps into play. Now that accomplishes higher availability because to the users, they don't realize that the server has gone down. They don't realize that there's an active passive on the back end. All they know is that they have availability to their services. Now there's a perfect situation that shows where uptime of a server is not necessarily high availability. Because if you have two servers side by side that are clustered, let's say, in an active passive situation, and a user is accessing their mailbox on, let's say, the active mailbox server role, and some crazy employee goes postal, grabs that server, and throws it out the window, obviously affecting the uptime of that server. If the crazy person is tackled before they can attack the passive server, well, then the user would never actually know that their availability has been affected in any way whatsoever, because the passive would realize there's a problem, would assume the active role, would continue to support the user who is checking in on their services, their mailbox, or whatever it is, and the user would be none the wiser. So that shows that there's availability, but not necessarily uptime of the active server. So clustering technology actually is something you might use to achieve high availability. However, again, it's not a prerequisite for a high availability solution. Typically, high availability is measured in percentages of available time. Now, that's usually in circumstances where it's measured at all. In many organizations, if you're the one providing the fault tolerance, clustering, high availability solutions for your organization, you don't necessarily have the time to measure the percentage of availability for those servers. However, when high availability is measured, and let's say you have a service level agreement with another organization to provide that high availability, you'll see that they will give their availability percentages as 99%, 99.9%, 99.99%, and so on. And typically, the amount of money you spend is what will account for the higher percentages. Because for everything you do, it's going to take money to make your situation more highly available. For example, if you want to include a stronger fault tolerance structure, well, you're going to have to put some money into it. If you want clustering technology, again, there's money involved. So for every step you take to ensure that nothing will cause downtime in any way, nothing will take away from the accessibility of services for your organization, for every little percentage point that you increase, you're going to spend money to accomplish that goal. However, as time progresses, the amount of money that you spend is actually reducing because these technologies are becoming more and more common. So, just to sum up here at the bottom, high availability is more of a concept than any one specific technology type. Yes, you may use fault tolerant disk architecture, you may use clustering technology, you may use third party tools that will help you to ship things off site, to create duplicates of your data, to create duplicates of your Exchange organization. You might use virtualization technologies. There's all sorts of different technologies that you can utilize to create a more highly available Exchange organization. And in fact, there are a few things that are included with Exchange 2010, and that's what we're going to talk about in this video, some of the solutions that are available to us in Exchange 2010. Before we do that, however, it's important for you to understand a little bit more about some of the Exchange architecture so that you know what's happening behind the scenes when it comes to your Exchange organization mailbox storage. Let's talk about storage architecture first, and then we'll move into a discussion of database availability groups for your Exchange 2010 organization. So first of all, storage architecture. When we're talking about storage architecture, we're talking about how the mailbox server role handles all of the emails that come flying into it, how it puts those emails into a database, and how that database is protected. Now, Microsoft could just say, well, there's a database and it's up to you to protect it. But one of the things that they did was they established transaction logs which assist in keeping your storage up to date. So the way your mailbox server handles mail coming into it is here it gets this email. And the email could be something small, it could be just a couple of lines, it could include a media file of some sort that's going to bulk up the email itself. It could be a picture, a song, a video. And so that becomes more problematic because all of those items now come into that mailbox server and it has to figure out how it's going to break it up and put it in the database. Well, that's something that the mailbox server is designed to do. When email comes into that mailbox server, it's written to memory and it's written to what's called transaction logs. Now, what these transaction logs are is they are duplicates of that information that is going to be written into the database. The transaction logs are 1 megabyte in size. And so as the database becomes available for more information, transaction logs are put into the database, but they're not erased from the server. At least by default, they're not erased. You can actually make it so that they are erased. So you might say, well, what's the benefit of having a database and transaction logs? Well, one of the benefits right out of the box you can easily see is that let's say Monday night comes around and you do a full backup of your database. Well, that's great. At that moment in time, you can restore that database if it becomes corrupted in some way, and your users will be none the wiser. Everything is exactly as it should be. They'll be able to access all of the same mail when they come in Tuesday morning as they were able to see Monday because you have a backup of the database. At that point, the transaction logs for that database can be purged because you already have a perfect duplicate. However, as users are working throughout the day on Tuesday, let's say the database becomes corrupted in the middle of the day. Well, you don't have a backup of the database in the middle of the day. You only have your backup from the night before. Well, that's okay because you can actually restore your database from the night before, and the transaction logs will replay themselves into the database, and hopefully users will not see a difference between their mailbox as it was prior to the corruption and their mailbox after the restoration. That's the beauty of the transaction log. However, let's say the problem is not that the database went corrupt, but rather that the disk itself blew up. Well, you might say I would certainly make sure my database is put on a RAID 5 volume so that it's completely protected in the event one disk were to blow up. And that's good advice, actually. If you are setting this up, you do want to make sure your database is protected that way with some form of RAID level, maybe putting it on a shared storage SAN, something of that sort that has these types of protections built in. Okay, but let's say you didn't. Let's say you have your database on one disk and that disk explodes. Well, your transaction logs would be very helpful with the restoration. However, in a one disk situation, what if your transaction logs are actually on the same disk as your database, and that disk blew up? Well, now you have a problem. So the recommendation is that you separate your database from your transaction logs, two separate disks. You put the database on one disk, you put the transaction logs on a completely separate disk. Beyond that, the recommendation is that you mirror your transaction log disk and you put some sort of RAID 5 fault tolerance in place for your database. However, that database can still go corrupt. Now, you might be noticing that we keep talking about a database. In previous versions of Exchange, there were storage groups that were used to organize these databases. However, these have been eliminated in Exchange 2010, and so the focus is on the database itself. And you're going to see when we create a database availability group that it's the databases that matter. Storage groups are completely gone. So if you've never touched a previous version of Exchange, then you have no idea what a storage group is, and that's okay. They were more like folders than anything else in the sense that they held together the databases and their transaction logs. And you might have multiple databases within a storage group, and so those transaction logs would get all mixed together within the storage group. That was a bit of a mistake architecturally, and so in Exchange 2007, Microsoft encouraged us to separate this a bit. For every one storage group, we would have one database. And so if that was going to be the case, the idea was in Exchange 2010, why have storage groups at all? And so we don't have them any longer. If you remember a previous version with storage groups, they're completely gone. We're focused completely on the database itself. Let's take a moment and go back over to our Exchange server and take a look at how the database and transaction logs actually look in order to get a better understanding of how the architecture works so that we can see that it's really not something to be afraid of. It's something that we can easily embrace. Okay, so here we are on our Exchange server. But you might note that there's something a little bit different about this Exchange server, and it's not just the fact that I have these panes all squished together here. I'm doing that so that I can show you that we have a different Exchange server. You'll note that we have now the Chicago Exchange server, and this is connected to our New York Exchange server. This server is only running the mailbox server role. Now it's good to take note that even though it's only running the mailbox server role, the actual Exchange Management Console shows all of these other different options here. And that's not meant to fool you. For starters, here we have organization configuration up top, so you can still configure the organization from here. But when it comes to server configuration and so forth, you can actually manage other servers, even though on this server we're only running the one role. So what we needed to do, if we were going to show you high availability at some point in the future, we needed to make sure we had another Exchange server. You can still see, however, if we just expand this out, that our mailbox databases, mailbox database 1, is still located on New York.ex2k10-1. Mailbox database 2 is also there. Our public folder database is there as well. Although with a second Exchange server, we could replicate some of the public folders off to this server. But what we're looking at here is the automatic mailbox database that was created when we installed the server. So here you see Chicago, or CHI for short, -ex2k10-2. Now what we want to do is take a look at the folder that's holding this database on the server itself. You can see up here that the database file path links off to program files, Microsoft Exchange Server, mailbox, mailbox database, and so on. So if we go over to our folder structure, you can see that I've already navigated to it for the sake of time. But the goal here is to take a look at the database and the transaction logs. So here's what we see. We have the mailbox database right here. That's the one that has the EDB extension. And you can see here it literally says EDB. There's also a temporary EDB file that's located here. And then you see all of these other files. So this file here, E00, this is actually the current transaction log. So as this server receives more emails to be put into mailboxes, this transaction log file will be renamed, and you can see the naming structure here. This was the first one, here's the second, here's the third, and of course you can see that each one is only a megabyte in size. So if an individual received a very large email, that email would be put into the database certainly, and the database would grow in size. However, at the same time, transaction logs would be added, and those transaction logs would break up that email into chunks of 1 megabyte. Now, you might get a couple of different emails that are, let's say, less than 1 megabyte, and so they would not each get their own transaction log. Instead, each email would go into a transaction log file. So let's say you have 3 or 4 that make up one transaction log file. And so you can see how these transaction logs can really grow in the course of a day. As individuals in a company might receive scores of emails each day, these transaction logs will just continue to grow. You'll notice up here that there's a checkpoint file. Now, this is an important file because what happens is these transaction logs are played into the database. But at times, there may be some kind of a glitch. It could be a power outage. It could be something significant that happens on the server that may make it so that a transaction log is right in the middle of being played into the database. And let's say it doesn't complete. Or let's say the database is not as up to date as it should be when it comes to the transaction logs that are in place, because the transaction logs are actually created first. And so when it comes to moving those logs into the database, there's a checkpoint file that will keep track of which pieces have not been put into the database itself. So you hope you never need that checkpoint file, but it's good to know that it's there. Okay, so now let's go back over to the slides and let's talk about continuous replication. This was a special new feature that was added to Exchange 2007 to provide high availability, and it's something that carries over to Exchange 2010 as well. Now, one of the other things that Microsoft did with Exchange 2007 is they introduced the idea of continuous replication. With continuous replication, the database is copied initially, and then your log files are shipped over and replayed constantly to keep that database up to date. And so when Exchange Server 2007 shipped, it shipped with two different versions of continuous replication. One allowed for replication from disk to disk within a system, and that was called local continuous replication. The other allowed for a clustered situation called cluster continuous replication, and that allowed you to have transaction log shipping over to another system. So we had LCR and CCR replication. With Service Pack 1, another form of replication was introduced called standby continuous replication. This allowed for site resiliency so that you could actually ship the database and logs over to another system in another site altogether. And so these three different high availability solutions were included with Exchange 2007, and they all utilized continuous replication. However, in Exchange 2010, all of these previous forms of high availability are done away with. They're gone. Now we have what's called database availability groups. We're going to talk about the features of a database availability group in a moment. But it's important to note that even though a database availability group is different from the previous forms of high availability that were allowed in Exchange 2007, the underlying structure is still similar in that continuous replication is used. And so when you first set up a database availability group and you determine where you want those databases to go, your database will be copied over to the other server that you designate. And then at that point, for all of the mail that comes in and gets added to the database and gets added to the transaction logs as well, those transaction logs are shipped over to the database availability group partner or partners. And so transaction log shipping and replay is something that's still a valuable thing to understand if you knew it from Exchange 2007. It hasn't gone away with 2010. The logs are shipped over and they're replayed into the database so that the database is kept as up to date as possible. Okay, so let's talk about some of the database availability group features before we actually take a look at how we're going to create one of these. Now, to start with, database availability groups do use continuous replication. And so we talked about how continuous replication was introduced to us in Exchange 2007 and is a great concept. Instead of having to ship over the database or stopping the database and moving it over, they use the transaction logs, ship those over, and replay those into the database. So database availability groups continue to use that same technology. Now, beyond that, it also allows for up to 16 different servers. Think about it. What that means is that you can have a database on server number 1, and you can actually replicate that database off to 16 other servers if you'd like. Now, you might say, well, that's a bit overkill. I don't know if I need 16 different servers to have a replica of my data. But that's your decision. That's something that you have the flexibility of deciding. Some of those servers may be close by, others may be in a completely different site, hopefully in a different geographic location if your organization is that large. So there's a lot of flexibility here with database availability groups. Now, in order to accomplish that, it's going to use some of the clustering features like heartbeats and file share witness in order to connect members of a database availability group. And so your Exchange server is going to require failover clustering components. Now, what that means, if you know your server editions, is you're going to need at least the Enterprise Edition of Server 2008 in order to provide the failover clustering components that are necessary, because clustering services is not a part of the standard edition. However, you might be thinking, okay, well, I don't know exactly how to set up clustering services. Now, that was something you needed to know with Exchange 2007, but you don't need to know this for Exchange 2010. So they've lifted off the requirement there for you to now learn clustering when it comes to establishing high availability. When it came to 2007, 2003, and earlier, you had to learn about clustering services. You had to understand how clustering worked in order to really provide high availability. But with database availability groups, it taps into those features without you actually having to know how to work with those features. So that's a good thing. There are some concepts that you still want to know about if you're going to have a DAG group. For example, when we say that it looks for a heartbeat, this is a very simple method where servers will check in with one another to ensure that they're still alive. So a server will send out a heartbeat and say, I'm still alive, I'm still up and running. And that's good because then the server that's standing there waiting with a replica of the data doesn't have to get nervous and take over the process. That would be a bad thing. But in the case of the heartbeats, if the heartbeat stops, then immediately the replica server thinks there's a problem, I need to go into action here. But that's where there's a file share witness, which is actually a method of providing a referee between DAG members. This is in the event that it appears as if one has gone down. It's good to have a second method in place to ensure that the server that now steps up with the replica should actually do that, because that heartbeat might have been interrupted for any number of reasons, and so it's good to make sure that there's a second witness in place to ensure that the replica should in fact become the live master. There's also an ability with DAG groups to lag the log replay during the configuration so that you can augment the time between when a corruption or virus might hit and when it gets replayed. This allows you time to stop the replay, and so if a corruption or virus hits that database, you don't want that to now get propagated out. You want to stop it in its tracks, and so with the log replay lag that you can actually create, this will give you the time to make sure you can stop it. The other thing you can do is you can perform point-in-time restores without going back to tape. And then even though in a cluster situation you might use terms like active or passive, when it comes to a DAG group, the term live master is utilized, and that's used to designate the active database. So the active database is the live master. So before we actually configure this, it's good to take a look at what DAG actually can represent visually, what it might look like if you're implementing this on multiple systems. So in our scenario here, we have System 1, System 2, and System 3, and each of them has their own database. They all have their own mailbox databases that they worry about, and there's users that are in those databases. So System 1 has Database 1, System 2 has Database 2, System 3 has Database 3. However, you want to make sure that you have replicas of these, and so you've decided that you're going to put a replica of each one on each individual system. And so that's what we see here. We see that System 1 has a replica for 2 and 3, System 2 has 1 and 3, System 3 has 1 and 2. And so this may remind you a little bit of fault tolerance, but instead of it being on a disk level, we're looking at an entire database that is replicated between these different servers. Now, if you just consider the amount of space you're going to need for that, let's say database 1 is 1 terabyte, and so is database 2 and database 3. Well, then you're going to need to make sure that you have 3 terabytes worth of space for each system so that you can have the replicas in place. The other thing that's good to consider is that you don't necessarily have to have a replica on each individual server. So System 1, it might only contain replica database 2, but not replica database 3. Maybe System 2 has replica database 3. Maybe System 3 has replica database 1. And so you can see that you can stagger out your database replications, and this way you don't necessarily have to have all of that disk space. It's completely up to you. Then again, you might have a system that's located in another site, and its primary purpose is to hold replicas of the database so that you have some form of site resiliency. So you might want to have in-house resiliency for your location, as well as site resiliency in the event there's a major disaster where you're located. But you can see how so many different technologies have to come into play here in order for you to have high availability. We're talking about the amount of disk space you're going to need for this type of protection. We haven't even touched upon the type of fault tolerance that's already in place for each replica. Then you're looking at having various lines that get connected to other locations, other sites perhaps, and we're looking at multiple servers, multiple database availability groups. So with each step we take to provide higher availability, it's going to cost us in time, in planning, in deployment, and so it's all part of the package when you're starting to figure out what level of high availability you want in your organization. It really comes down to the amount of money you can spend. Okay, enough talk. Let's go over to our server and let's actually take a look at how we implement the database availability group. It's really very, very simple. You're going to be surprised at how easy it is to set up a database availability group in Exchange 2010. Okay, so here we are back on an Exchange server. Now we're not back on the New York Exchange server, we're actually on the Chicago Exchange server, and we're going to establish the database availability group first, and that's something we do at the organization configuration level. So we could have done this on any one of the servers. The Exchange Management Console would have allowed us to do this on the New York server, and actually we set up a third server that will host the hub transport role. So we'll explain that in a moment. Let's get the database availability group started. There's three parts to establishing some form of resiliency for your database. The first part is establishing a database availability group. The second part is adding members to that group. So just because you establish a group or multiple groups does not necessarily mean that you want to put your servers in those groups. So it's completely up to you. You can opt in or out for a particular mailbox server. The third part is to then go to the Database Management tab, find the database that you want to have replicated, and replicate that database between members of the group. So you can't replicate a database to a server that's not a member of a particular group. You'll see in a moment that it's all very organized. So let's get started by creating our database availability group using the new database availability group wizard. Okay, and here we have the new database availability group wizard. Now it's a pretty simple wizard. There's three things actually that you have to be concerned about. The first is providing the database availability group name. So in this case, we'll make it something simple like database availability group 1. Now notice the next two parts, a witness server and a witness directory. Now here's the deal. If you want to establish a database availability group, you need at least 3 servers. 2 servers have to be mailbox servers, and you're going to replicate between those 2 servers. That's the bare minimum in terms of mailbox servers, because obviously you need to replicate towards another mailbox server. So you need at least 2 of those. Now, with Exchange 2010, the misconception is that being that the mailbox servers can be installed on the same server as a hub transport server, the idea is, oh, well, then I only need 2 servers, and I'll make one of those a hub transport server. But when you're setting up a database availability group, you need to have more than 2 servers because you remember we talked about the heartbeat and we talked about the file share witness. Well, if those 2 servers are not able to communicate for whatever reason, let's say the connection between them is cut in some way, and the live master is not able to verify that it's still alive and functioning, well, you don't want to have that split brain syndrome. So you need to have a third witness, a third server that acts as a witness, and it's really just a file share witness. It's simply a shared out directory that allows both servers to contact this third server and say, hey, we're doing fine here, even if the heartbeat isn't functioning properly. So this is where you need a witness server and a witness directory. Now the recommendation is you use a hub transport server for the witness server. So here's what's going to happen. We have a hub transport server on a separate server altogether, and that's the only role that it's running so that we could set up this database availability group. So we configured a third server in order to make this happen. Now, we're not going to put in a witness server here because what will happen is if we don't put in the witness server here, it will automatically go out and find a hub transport server that's not running the mailbox server role, and it will just use that server. In our case, we only have one, so it's pretty easy. We don't have to start worrying about typing in all the information here for the host name or fully qualified domain name. It's all going to do it itself. As far as the witness directory, if we wanted to determine a specific one, we could do that. We could click the little checkbox and we could determine what our specific witness directory will be, but we're going to leave this blank as well. and we're going to let the wizard create it for us. And so you'll see what exactly is created and where on a server by default. And that may give you some ideas as far as doing it yourself if you wanted to do it manually sometime in the future. Okay, so we have our name. The system will find the witness server and create the witness directory. We click New, and it completed. Pretty simple, actually, right? So we click Finish, and you can see here is the name of our database availability group. We have no member servers in place just yet. We'll add that next. Here is the witness server that we created. So there it is. There's the hub transport server that's standing on its own. And here's the witness directory. So you see it created a witness directory under DAG file share witness, and that's actually located on this hub transport server. So all of that was done for us. However, obviously you can click those checkboxes and do it yourself, and that may especially be helpful in situations where you have more than one hub transport server that can be chosen. So you may have a specific one in mind for your witness server. Well, the next step is to add our other two servers as member servers. So we right-click the database availability group, we click Manage Database Availability Group Membership, and from the wizard here, we click Add in order to add in our two servers, the New York and the Chicago Exchange servers. And there they are. We select them both, we say OK, and then we click Manage. And we can see here that the Chicago server has been made a member of the availability group. And as you can see now, the second one, New York, that completed as well. So we click Finish. And as you can see here, we have DAG Network 1. We have replication enabled, subnets, network interfaces. This is a little bit deeper of a discussion that we'll hold off for a future time. But for those of you who are clustering experts that may be watching this, you realize that we haven't even touched clustering services at this point. Here, these two servers are clustered in a sense. They're member servers of a special database availability group, and that ties them together. Now, we haven't made the move to replicate any data at this point, but we have everything in place. We have the infrastructure in place to accomplish the replication of data, and we did it without even touching clustering services. So that's a real nice feature to Exchange 2010. We don't have to delve into the world of clustering if we don't want to. If we click Database Management, we'll just look at the last part of this. Here we have the mailbox database on the Chicago Exchange server, and we're just going to create a replica of this off to our New York Exchange server to make sure that this database is protected. So to accomplish that, we can right-click the database and click Add Mailbox Database Copy. Okay, so the server that already has the copy is Chicago. We're going to click Browse and choose our New York server here to create the copy over to the New York server and click Add. And that's all there is to it, really. We click Finish, and now you can see that the copy of this database is on both Chicago, which is mounted, and we have New York 1, which is healthy. This lets us know the information we need to know. If this server were to go down for any reason, the New York server has a healthy copy of the database and can go right into action. And so that will prevent the Exchange mailbox services from being unavailable to our users. See, that's the point of high availability. We're not saying that we can protect every server from going down or every disk from going bad. There's various technologies that are in place to accomplish that to the best of technology's ability. But when all else fails, if you can have a replica of the data waiting and ready to take action to go into effect in the event the server goes down, well, then that is how you provide higher levels of availability. So here you can see how easy it was. We set up a database availability group. We had our two mailbox servers join as members, and here we just created a replica of that data from the Chicago server to the New York server. Folks, it just does not get more exciting than this. And look at how quick and easy it was. Now, granted, there is some time involved in the setup. In the video, we avoided showing you the time it took to set up the Chicago server and the extra hub transport server. That's all going to take time. And of course, that also takes some extra funding in order to have those servers. You need to have the enterprise version of the server running because we're working with clustering services, even though we're not installing clustering services per se. Personally, there are features that are being installed behind the scenes there that come out of clustering services, which is part of the enterprise edition of Server 2008. So that's all stuff that you have to keep in mind, and it is going to take you time. But once that's all in place, look at how easy it was for us to set up our group and to establish a replica of our data.